So we're going to be doing Check Your Understanding for topic 6.7, which, as we recall, is the fundamental theorem of calculus, which basically says if I have this is called a definite integral from a to b of f of x dx, it's equal to the antiderivative of f of x from a, evaluated from a to b, or really we tend to say this becomes that, okay? Where f of x is the antiderivative. F of x is the antiderivative of f of x. Or in other words, f prime is equal to f of x. I don't know if I've defined antiderivative in class. It felt like that was new all of a sudden. So antiderivative just means the undoing the derivative on the function. Okay, the other thing I wanted to make sure was really clear here is if I'm given an initial value or an initial amount or an amount at any time. So initial usually is the beginning. Basically, if they give me a number. These two match, so whatever the x value is, or the input value, and then the number they gave me, up to whatever number I'm trying to find. So these two are the two I'm trying to find. Let me kind of triangle those. Trying to find, okay? So just something to think about. Okay. That said, the temperature of water in a tub is given by a strictly increasing twice differentiable function w of t. Selected values of w of t are given in the table below. So twice differentiable means w of t is continuous since it is continuous, and so is. That's important. Okay, so anyway, evaluate the integral from 0 to 20 of w of t dt. Interpret your answer in context of this problem, w prime of t dt. So we know from the fundamental theorem that we were just looking at, I'm going to change to a different color, that this is going to be the integral antiderivative of w prime of t is w of t. And we're going to evaluate that from 0 to 20, which will be equal to the w of 20 minus w of 0. From our table, w of 20 is 71, and w of 0 is 55, and 71 minus 55 is 16. That's it. Okay. Okay. Interpret our answer between 0 and 20. I guess we'd say t equals 0 and t equals 20. The temperature of the bathtub, water in the tub, of the tub, I don't know if it's bathtub, tub, the temperature of the bathtub at a net change of 16 degrees. Okay, so net change. So we notice, I mean, this is strictly increasing, so that's pretty straightforward. But since it's continuous, this is a total change over time. Okay, period. All right, let's see what happens next. The graph of g prime is given below. If g of negative 2 equals negative 12, find g of 4. So g of 4 is going to be equal to the number they gave me, g of negative 2, plus the integral from negative 2 to 4. So again, negative 2 being this number that was given, and 4 being the number I'm trying to find. So that's where everything goes in the interval, of g prime of t of x, dx. Okay, so this, we know two things about this. One, I could use a calculator if I knew what g prime was. I don't. But it's the area under the curve. So when I look at this curve, we have a semicircle, or half a circle. That's what semicircle means, and a triangle. So all I need to do is find the area and add it to this. So what I'm going to get is g of 4. As well, color. Oops. G of 4 equals g of negative 2 was negative 11 plus the areas. So this is half a circle, so 1/2 pi r squared. R is 2. So 2 squared, 1/2, because this is a semicircle, pi r squared, plus the area of the base, which is 1/2, which is 2, times the height, which is 2, divided by 2, or times 1/2. Anyway, doing a bunch of math, I get negative 11 plus 2 pi, so it'll be 4 pi divided in half, plus 2, which is negative 9, plus 2 pi, and that's going to be my answer. Two pi is about 6, so the answer is still negative. Okay. Multiple choice. If g is the antiderivative of f of x and g of 3 is 5, then g of 8 equals. Okay, so g is an antiderivative of f of x. Let's just write that down. G prime of x is f of x. That's what that means. Since g is the antiderivative, g of x is equal to the integral of f of x dx. Okay, or this. Both of those are true. So if g of 3 is 5, and then g of 3. So we're looking at our answers. F prime of 8, the integral from 3 to 8 of f of x, the integral from 3 to 8 of 5 plus f of x dx, 5 plus the integral from 3 to 8 of f of x dx. I don't think it's A. What do you think? It is D. Same work that we just did in number 2. Okay, evaluate. We're evaluating 3 of these. And they're really not that bad. So let's go ahead and do number 4. The antiderivative of 3 is 3t, since we're taking the derivative with respect to t. Antiderivative from 4 to 10 is going to be equal to 30 minus 12. 3 times 10. I'm just plugging in those numbers, which is equal to 18. So then the integral of 3t, the antiderivative of 3t will be t squared divided by 2, so that the 2 goes away, from 4 to 10, which will be equal to 3 over 2 times 100 plus 3 over, minus 3 over 2 times 16, 3 over 2 times 100 minus 16, just factoring out, because I can do the math better in my head this way. It's going to be 84. 42 times 3. 126. Okay. Now, for response question, stopping here. Stopping even there. This is not the free response level question, though. You're going to have to go to 126. Okay. And last but not least, the antiderivative of 3t squared, again, from 4 to 10. So the antiderivative of 3t squared will be 3t to the third divided by 3, which is just t cubed, evaluated between 4 and 10. And officially I should be evaluating between 4 and 10 to keep it equal on both of them. And so we've got 100 cubed minus 4 cubed, which is 1,000 minus 64. Not 100 minus 64, 1,000 minus 64. Which is 936. That's it. All there is to it. Oops. Of course, showing it would be helpful. Easy. Easy, easy breezy. Now in case you're curious about the integration, we're using backwards power rule, which is the easiest one to go backwards on, right? So what did that have to be? It had to be 3t, so the 3 would still be there. I had to, power rule bring the 2 down times, but it wasn't there anymore. The 2 wasn't there. Whereas in this one, the 3 was there. So you don't really need this. Sometimes we can just see as t cubed, but that's it. All right, we'll see you guys soon. Have a great day.